first thing he wants us to do to graph this is to find a vertical asymptote. You always find a vertical asymptote by setting the denominator equal to 0. So I've done that here. To find the vertical asymptote, take the denominator, set it equal to 0, and we get a lovely vertical asymptote of 2. Next thing he wants us to find is the horizontal asymptote, and that's where you're playing the comparison game. If the degree of the top, this 2, is bigger than the degree of the bottom, there actually is no horizontal asymptote. There's a slant asymptote instead. And when there's a slant asymptote, we have to do long division, unfortunately. So we set up our long division, x squared, maybe a placeholder for that x plus 1 divided by x minus 2. And we ask ourselves, what do we multiply x by to get x squared? We say x, then we multiply this times all that. I think we did it over on the side here. X times x minus 2 gives us x squared minus 2x. I'm going to put that underneath here, x squared minus 2x, and remember we change the signs and add. So changing those signs and adding, we have 2x, bring down the 1, and we do it again. So now we ask ourselves, what do we multiply x by to get 2x? We say 2, and then we do 2 times all that, so 2 times the x minus 2, gives us 2x minus 4, and we'll put that 2x minus 4 underneath here, so 2x minus 4, and then we change our signs and add. So those go away like we planned. 1 plus 4 is 5, and we can't go any farther. So this, I'm going to say y equals x minus 2 is our slant asymptote. We'll deal with that later, but we've got a vertical, no horizontal, but a slant. And now he wants us to find x-intercepts. You know you can always find x-intercepts by letting y equal 0. Remember this f of x is like y, so this is equal to 0, so we're going to have 0 equals the function. So I'm going to say 0 equals x squared plus 1 over x minus 2. And if I were to multiply both sides by that x minus 2, it just goes away. So basically, it's just setting the top equal to 0. That's what this kind of is going to feel like. Because x minus 2 times 0 is just 0. Those cancel. So basically, we're looking, where does the top equal 0? So if I solve this by subtracting 1 from both sides, I get negative 1 equals x squared. Now to undo the square, I need to take a square root. And so I've got the square root of plus or minus the square root of negative 1 equals x. But you're like, I can't take the square root of negative 1 in the reals. So this doesn't exist, so there are no x-intercepts. Bummer. How's that? So no x-intercepts. Let's see if there's a y-intercept. You can always find a y-intercept by letting x equal 0. Just plugging that back in all the way to the original. So y will equal 0 squared plus 1 over 0 minus 2. So writing that down here, y will equal 0 squared plus 1 over 0 minus 2 to give you 1 over negative 2. So that's your y-intercept. So now we have to graph it. So our recap, we got a vertical asymptote of x equals 2, a horizontal asymptote of y equals x plus 2, no x-intercepts, and a y-intercept of negative 1/2. So the vertical asymptote x equals 2 is going to go through, there's x equals 2, so this line here is our vertical asymptote. Our horizontal asymptote is this line, so it's got a slope of 1, it's because of that invisible 1 right there, so a slope of 1 and a y-intercept of 2. So start by plotting that y-intercept, and from that point use your slope to go up 1 and over 1, up 1 and over 1, up 1 and over 1. So there is your slant asymptote. We've got a y-intercept of negative 1/2, so it's going to cross the y-axis at negative 1/2. And so when I go to draw this thing, it's going to come close to these asymptotes. So the one down here has got to pass through this point, come close to that asymptote, and come down here, come close to that asymptote. And then there's going to be a one up here. I'm just going to have it come close to this asymptote and close to that asymptote, kind of hug those rails, and that is your final answer.